Right now, at this very moment, an object born around a star that is not our sun is tearing through our solar system at more than 200,000 kilometers per hour. It has been traveling through interstellar space for billions of years, and some scientists believe it may be older than the sun itself, older than the Earth, older than every single rock on this planet. It is only the third visitor from another star system that humanity has ever detected. And almost everything about it, its chemistry, its age, its strange behavior near the sun, has turned out to be stranger than anyone predicted. Stick around, because by the end of this video, you'll know exactly what scientists have actually confirmed about the object called 3I/Atlas, and which the wild claims circulating online you should not believe. And if real space discoveries explained without the exaggeration are your kind of thing, hit subscribe right now, because this object is still out there, still being tracked. And this story is not over yet. Look up at the night sky on any clear evening, and every point of light you can see, every star, every planet, every faint smudge of a distant comet belongs to a system we at least partially understand. For all of human history, every comet and every asteroid ever observed was born here, inside our own solar system, formed from the same spinning cloud of gas and dust that built the sun, the Earth, and you. Every single one. Until October of 2017. That impression of a closed, self-contained solar system turned out to be misleading, because our galaxy, it turns out, is full of wanderers. Objects thrown out of their home star systems billions of years ago, drifting silently between the stars. And every once in a while, one of them passes through ours. The story really begins on October 19th, 2017, when an astronomer named Robert Warwick, working with the Pan-STARRS telescope on the summit of Haleakala in Hawaii, spotted a faint point of light moving in a way that made no sense. When researchers calculated its orbit, they found something no one had ever seen before. The object was not bound to the sun at all. It was moving too fast, on a trajectory that could only mean one thing. It had come from outside the solar system, and it was leaving forever. That object became known as Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. And it was deeply, genuinely strange. Radar and light measurements suggested it was extremely elongated, possibly 10 times longer than it was wide, a shape almost never seen in nature. It tumbled end over end. It showed no visible tail, no coma, none of the classic signs of a comet. And as it left, it did something that ignited years of scientific debate. It accelerated ever so slightly in a way that gravity alone could not explain. Some scientists proposed exotic natural explanations. A fragment of frozen hydrogen, a shard of nitrogen ice from a distant Pluto-like world. One Harvard astronomer, Avi Loeb, famously suggested it might be artificial. The frustrating truth is that we will never know for certain. Oumuamua was discovered on its way out, already receding, and it was gone before our best instruments could study it properly. The first confirmed visitor from interstellar space slipped through our fingers. 2 years later, in August of 2019, an amateur astronomer named James Borisov, using a telescope he built himself, found the second one. 2I/Borisov looked far more familiar. A fairly ordinary comet with a tail and a coma, just one that happened to be passing through from another star system. 2 visitors in 2 years taught astronomers a crucial lesson. These objects are not rare. We had simply never had instruments good enough to catch them before. And where there are 2, there are many. So the question became, when the third one arrived, would we be ready? On July 1st, 2025, a telescope in Rio Hurtado, Chile, part of a network called ATLAS, the Asteroid Terrestrial Impact Last Alert System, a system designed to warn humanity about incoming asteroids, flagged a faint moving object in the constellation Sagittarius. At first, it was just another entry in a nightly stream of detections, tagged with the temporary designation A11PL3Z. Then, astronomers around the world began calculating its orbit, and the numbers that came back made people sit up in their chairs. Every object orbiting the sun follows a path with a property called eccentricity. A perfect circle has an eccentricity of 0. Stretched ellipses get closer to 1. Anything above 1 is not an orbit at all. It is an escape trajectory, the path of an object that is not bound to the sun and never was. Oumuamua's eccentricity was about 1.2. Borisov's was about 3.4. This new object came back with an eccentricity of roughly 6.1. The most extreme ever recorded for anything passing through our solar system. There was no ambiguity. This thing had come screaming in from interstellar space at nearly 60 kilometers per second. That is fast enough to cross the entire United States, coast to coast, in about 80 seconds. Within days, the object received its official name, 3I/Atlas, the third interstellar visitor ever discovered. And this time, unlike with Oumuamua, we caught it on the way in, with months of warning before its closest approach to the Sun. For the first time in history, humanity had a real chance to study a piece of another star system with everything we had. The first questions were the obvious ones. How big is it? And is it dangerous? Early brightness estimates allowed for a nucleus as large as several kilometers across, and headlines immediately ran wild. But when the Hubble Space Telescope captured its first sharp images in late July 2025, the picture became clearer. Hubble set an upper limit on the nucleus of about 5.6 kilometers, and the data suggested it could be far smaller, possibly under a kilometer. The uncertainty exists because 3I/Atlas, unlike Oumuamua, is an active comet wrapped in a glowing cloud of dust and gas that hides the solid nucleus inside. As for danger, the answer is a clean and simple no. The trajectory was locked down quickly and precisely. Its closest approach to Earth in December 2025 kept it roughly 270 million kilometers away, nearly twice the distance between the Earth and the Sun. It never came anywhere close to us. Whatever else this object is, it was never a threat. Then the measurements started coming in. And this is where 3I/Atlas stopped being merely exciting and started being genuinely strange. The first surprise was its age. By tracing its incoming trajectory backward, astronomers found that 3I/Atlas did not come from the flat, calm disk of the galaxy where the Sun lives. Its path and speed suggest it belongs to an older, more turbulent population of stars, what astronomers call the thick disk. Objects from that population formed early in the galaxy's history. Statistical studies published after the discovery estimated that this comet is likely older than our entire solar system, with some analyses suggesting an age of 7 billion years or more compared to the 4.5 billion years of the Sun. Let that sink in for a moment. When this object formed around its parent star, the Sun did not exist. The Earth did not exist. The cloud of dust that would eventually become everything you have ever known had not yet begun to collapse. This frozen wanderer may have already been drifting between the stars for billions of years before our solar system was born. Scientists are careful to describe this as a statistical estimate, not a direct measurement. You cannot carbon date a comet from a telescope, but the trajectory data points consistently in one direction. 3I/Atlas is ancient, very possibly the oldest object ever observed inside our solar system. The second surprise came from its chemistry. In August of 2025, the James Webb Space Telescope turned its infrared instruments toward the comet, and what it found in the coma broke the pattern of every comet we have ever studied up close. Comets from our own solar system are, broadly speaking, dirty snowballs. Their activity is usually dominated by water ice turning to vapor as they approach the Sun. 3I/Atlas is different. Webb's measurements showed its coma was overwhelmingly dominated by carbon dioxide, with one of the highest carbon dioxide to water ratios ever measured in any comet. This is not a small quirk. The balance of ices inside a comet is a frozen record of exactly where and how it formed, how far from its star, at what temperature, inside what kind of chemical environment. A carbon dioxide-rich comet like this one may have formed closer to the carbon dioxide ice line of its home system, or its surface, may have been chemically altered by billions of years of cosmic radiation during its journey between the stars. Either way, researchers were looking at a genuinely different recipe, direct physical evidence that planetary systems around other stars build their comets differently than ours did. Ground-based telescopes added more pieces, traces of nickel vapor in the coma, cyanide gas, and water ice grains. A chemical fingerprint from a star system we will never see. If you're the kind of person who wants discoveries like this explained clearly instead of buried under either jargon or hype, take 1 second and drop a like on this video right now. It genuinely helps this channel reach more people who would enjoy it. As 3I/Atlas fell closer to the Sun through the autumn of 2025, it kept behaving in unexpected ways. It brightened faster than standard models predicted. Its color shifted. Observations showed it turning distinctly bluer than sunlight, a sign that the light from its coma was being dominated by glowing gas rather than reflected dust. And in early October 2025, something remarkable happened. The comet passed within about 29 million kilometers of Mars. Humanity's robotic fleet at the Red Planet, including NASA's Mars Reconnaissance Orbiter and Europe's ExoMars, traced gas. Orbiter turned their cameras away from the planet they were built to study and photographed an interstellar visitor passing by. Spacecraft engineered to look down at Martian rocks became, for a few days, the closest observers of an object from another star. Then, at the end of October 2025, 3 I/Atlas reached perihelion, its closest point to the Sun, passing just inside the orbit of Mars at around 68 kilometers per second. And here, the universe played a frustrating trick. At exactly the moment of closest approach, the comet's position placed it almost directly behind the Sun, as seen from Earth. For weeks, ground-based telescopes simply could not observe it. And into that gap of missing data, the internet poured every conspiracy theory imaginable. That the object was maneuvering, that it was hiding, that NASA was concealing what it really was. The truth is far less dramatic and far more ordinary. Solar conjunction happens to comets all the time. It is geometry, not mystery. Spacecraft in other parts of the solar system continued monitoring the whole time. When 3 I/Atlas emerged from behind the Sun in December 2025, astronomers immediately checked the one thing everyone wanted to know: had its trajectory changed in any way that gravity could not explain? The answer was yes, slightly. Precise tracking revealed a small non-gravitational acceleration. And before anyone reaches for the alien hypothesis, here is the crucial context. Ordinary comets do this constantly. A comet venting gas into space acts like a natural rocket engine. The escaping jets push the nucleus around in tiny but measurable ways. The acceleration measure for 3 I/Atlas is entirely consistent with a comet losing material as it heats up. This is exactly the kind of behavior Oumuamua showed without any visible outgassing, which is what made Oumuamua a lasting mystery. 3 I/Atlas, by contrast, is visibly and violently outgassing. The engine explaining its push is right there in the data. That has not stopped the debate entirely. Avi Loeb, the same Harvard astronomer who questioned Oumuamua's nature, publicly raised the possibility that 3 I/Atlas might warrant consideration as something artificial, pointing to its unusual trajectory through the solar system and its peculiar brightness behavior. The overwhelming majority of planetary scientists disagree, and it is worth being precise about why. This object has a coma, it has measurable gas chemistry, it sheds dust, it responds to solar heating exactly the way an icy body should. Every anomaly it displays, the extreme carbon dioxide ratio, the color, the acceleration, is unusual in degree but natural in kind. Nothing about it requires anything other than a very old, very foreign comet. Extraordinary claims require extraordinary evidence, and in this case, the ordinary explanation fits the data better at every point. That is not a cover-up. That's how science is supposed to work. I've read through an enormous amount of the published research on this object while making this video, and honestly, if there's another space mystery you want broken down with this same no-hype approach, drop a comment below and let me know, because your suggestions genuinely decide what this channel covers next. Now, picture for just a moment what it would actually be like to stand on the surface of 3 I/Atlas during these months, because the numbers make it almost impossible to imagine otherwise. Beneath your feet, a crust of ice and dust darkened by billions of years of cosmic radiation. A surface that has drifted through absolute darkness at temperatures near absolute zero for longer than the Earth has existed. Above you, a sky full of stars in patterns no human has ever seen from Earth. And among them, one star growing steadily brighter month after month. For the first time in billions of years, your world has weather. Jets of gas erupt from the ground around you as ancient ices, frozen since before the sun was born, boil into space. The sky glows with a haze of your own escaping atmosphere. And then, over a few short months, the bright star fades behind you. The eruptions die down, the cold returns, and your world goes back to sleep, beginning another journey through interstellar darkness that may last longer than the remaining lifetime of the star it just visited. Because that is the final strangest fact about 3 I/Atlas. It is already leaving. Its speed is far beyond the sun's ability to hold it. It is now climbing back out of the solar system, heading toward the outer darkness in the direction of the constellation Gemini, carrying its 4 billion-year-old secrets, or 7 or 10 billion, we may never know exactly, away with it forever. No spacecraft currently flying can catch it. The encounter lasted a few months. The wait for it lasted longer than human civilization. It's worth understanding a little more about how an object like this ends up wandering between the stars in the first place, because the mechanism says something remarkable about how violent the birth of a planetary system actually is. When a star forms, it is surrounded by a disk of gas, dust, and ice, the raw material of planets. As giant planets grow inside that disk, Their gravity starts throwing things around. Computer models of planet formation consistently show the same outcome. For every comet a young system keeps, it hurls enormous numbers of others into interstellar space, slingshotted away by close encounters with growing giant planets, expelled forever with no chance of return. Our own solar system almost certainly did this too. Early in its history, as Jupiter and Saturn settled into their orbits, they likely ejected trillions of icy bodies into the galaxy. Somewhere out there, right now, comets born around our sun are drifting past other stars. And if anyone is watching from those systems, our discarded debris is their interstellar visitor. The galaxy, in other words, is not mostly empty between the stars. It is crisscrossed by an invisible population of frozen wreckage from every planetary system that ever formed, each piece carrying the chemical signature of its birthplace. 3. I/Atlas is simply the third piece of the wreckage we have ever managed to catch in the act of passing through. And it's worth appreciating exactly how it was caught, because the system that found it was never designed for this job at all. The Atlas network, the Asteroid Terrestrial Impact Last Alert System, is a chain of robotic telescopes spread across Hawaii, Chile, and South Africa, built and funded for one purpose: planetary defense. Its job is to scan the entire visible sky every single night, looking for near-Earth asteroids on collision courses, ideally with enough warning time to do something about it. To pull that off, Atlas doesn't stare deeply at any one patch of sky the way giant observatories do. It sweeps constantly, comparing tonight's sky against last night's, flagging anything that moved. Most of what it catches is routine, ordinary asteroids, known comets, satellites. But a survey that watches everything all the time has a special power. It catches the things nobody was looking for. And that is exactly what happened on July 1st, 2025. A planetary defense system built to protect Earth from local threats ended up detecting a visitor from another star. And because it flagged the object early, on the way in, it bought the world's astronomers the one resource Oumuamua never gave them: time. Time to point Hubble at it. Time to schedule Webb. Time to coordinate spacecraft at Mars. The lesson has not been lost on the scientific community. The more the sky we watch continuously, the more the universe turns out to be sending us. So what does all of this actually add up to? 3 interstellar visitors in 8 years. After all of recorded human history produced 0. That is not because the galaxy suddenly got busier. It is because we finally learned how to look. Current estimates suggest that at any given moment there may be thousands of interstellar objects drifting through the solar system, most of them small, dark, and far too faint for today's telescopes. That is about to change. The Vera Rubin Observatory in Chile, which began operations in 2025, is expected to discover interstellar visitors at a rate no previous instrument could approach, potentially dozens over the coming decade. And the European Space Agency is preparing a mission called Comet Interceptor, designed to wait in space, parked and ready for a pristine comet or interstellar object on an incoming trajectory, so that next time we don't just watch the visitor pass by, we go and meet it. Every one of these objects is a free sample from another planetary system, a physical piece of a place we could otherwise never touch, delivered to our doorstep by nothing but gravity and time. 3 I/Atlas showed us that some of those samples are older than our own star, built from different ice, carrying different chemistry, evidence that the galaxy builds worlds in more ways than our single example ever suggested. And if one ancient comet from the thick disk of the galaxy taught us this much in a few months, it is genuinely worth wondering what the next visitor will be carrying, because the next one is already on its way, somewhere out there in the dark, whether we have spotted it yet or not. If stories like this one, grounded in real published research instead of recycled hype, are what you want more of, subscribe right now and turn on the notification bell, because Rubin Observatory is scanning the sky every single night, and there is a very real chance the 4th interstellar visitor gets discovered sooner than anyone expects. And when it does, you'll want to be here for it. Thanks for watching, and I will see you in the next one.